Hello, everybody, and welcome. I am here today with Felipe Montoya from EduNext, a longtime friend and Open edX contributor. And I am so pleased to be listening to his talk today about the Open edX events and filters framework. So take it away.
Okay, so OpenEdX events and filters. This is actually the part that I like the most is extending the OpenEdX platform sustainably, because as someone who's been working on this for like 8 years or so, extending it is it's fine, it's easy, but making it sustainable over time, migrate to new named releases and so on, that's the hard part. So a little bit of a background of what got us here, like what was our motivation. OpenEDX mostly does everything that you needed to do. There's that little part. There's the customer or the institution you work for or whatever your use case is. It just lacks that little final something. And it's open source, right? So you fork it and you tweak it. But then 6 months in, you have to redevelop your extension, your change, because the platform changed. So now you have to do a big merge or completely redevelop the thing that you were doing. 6 months go by and you need to do it again. And then you start thinking, why did I say yes on the first time? Like I could have just said, no, that's impossible. And my job and my life would be so much easier. And if that happens at one institution level, we used to work with, or we work all the time with multi-tenant instances. So we have tens, maybe hundreds of different institutions trying to run on a single platform. And this problem just became exponentially worse. But we did see architectural patterns start to emerge. We saw like most or oftentimes the institutions, the customers, the academies wanted small modifications in the same places where the existing extension points, although they are present and they exist, were not sufficient. And that time, at the time, we were all talking about the open close principles. We were coming to the conferences and seeing presentations by Nimisha about how we should extend, make it easy to extend the platform, but without having to touch the core. And this was ringing in my head, like we need to make this work. And we were also thinking about and working with the plugins architecture, something that you can install on the platform and change it without touching the core. It was the first steps of the open close principle. But we needed to, like, this was enough to add stuff to the platform, but it was not enough to modify what the platform was already doing. So we wanted more, like greedy, all the time. We always wanted to be able to change that little final something. So the hooks framework came to be. Internally at EduNext, we started having these experiences. We were using the same patterns over and over. We actually had like a small library that we would copy into the code of the platform and then use that small library for all our customers. And all of them would require some development, but with this little core, the part we were copying from installation to installation, it was easier. And at some point, the end of 2019, starts of 2020, we said maybe this is worth actually publishing and giving it away for the community. We might get feedback. It might be even better for us. So we just published some random thoughts in a public document on Google Docs, and we tried over the forums to get people to comment on it. And the comments actually came. Like it wasn't like a big rain of everyone wanted this, but comments started coming from different places, other providers, from architectures, members of the architectural council at edX that said, there's some good stuff here. You should polish it a little more. Maybe you want to make an OWeb. That's the way to go. So we said, let's make an OWeb. We'd never written a OWeb before, but we started publishing like the same document, just better format and having some discussions. The OWeb took about 1 year, which was a long time. But it was worth it because over that year of slow discussions, the best parts of this started to shine. We had a very complex way of describing what was happening, the extensions we wanted to make. We had a list, like a shopping grocery list of all the things that we wanted to extend in the platform, and we started to focus on what was most important, not only for us, but for the rest of the community. And eventually, February to May of last year, we meshed the OEP with the indication of the path that was meant to be, what we were going to follow. So then we got some attention from Nimisha, that was at the moment at edX still, and she said, this is worth doing, and edX is willing to participate on it. We created a blended project, and we started to actually try to put these ideas into code, because the OEP was still like a little rough on what the implementation was going to be. And we worked for the most part of last year. And by the time Maple was got in December, the first part of what I'm going to talk, the events part of the framework, was already in the platform. And then we continued working this year. And now what will be released in Nutmeg in June will have both parts. So hooks. Hooks are words have some certain charge, so like certain weight to them. And hooks and events and filters, the words I'm going to use a lot, already have some of that weight, even if I don't say or I don't explain what that means in this context. So I like to go with the simplest explanation, which is hooks are places in the code, in the life cycle of a student or an author, where something else can happen. An externally defined function can happen, where I can do something more than what the platform does. So let's take, for example, this very simple life cycle of a student. Student registers, enrolls in a course, learns. At the end of the learning, will probably have a grade, and with this grade, he or she will get a certificate. Hooks are the little white spaces, the little holes waiting to be filled with something. Maybe I want to take the information from the student before he or she registers and do something with it. Maybe I need to search for the name in some other database and make sure that they are actually allowed to register. Maybe the information I have from them is just an ID from the university, and I want to take this ID and go fetch all data that I have in the academic system and put it in the registration for OpenEDX. Or maybe I don't want to alter the registration before it happens, but after it happens. So the student registered, but I want to do something afterwards. I want to let a system know that this happened. I want to let Salesforce know that someone registered in my platform, so that I can start preparing to maybe sell a course for them. So those are hooks. Those are the different kinds of hooks. And we grouped them in order to understand and program them. We divided them into two big groups, depending from what's expected from them. So we call them events and filters. When we're talking about events, this is like broadcasting. The events, they don't halt the application. The application will not wait for the event to happen. It just happens. But the event, after some action occurred, normally, like events, that's the second bullet point, events normally happen after an action. So the student register, that's an event. And their main goal is stability. We want developers to be able to take an event and build on top of it and be absolutely 100% sure that their event will continue to exist in the platform in the same way, that it will not break. That if I publish a plugin that depends on a certain event, it will always receive the same information from the event, and I can trust that my foundations for developing are strong. Events live as code lives, but they are defined in a separate Python library, which makes it easy to import into my code. So we don't have what Dave Barnes we call the banana problem. You want to have a banana, but then you need to import the gorilla and the whole jungle to get that little sweet banana that you want. Instead of that, we have a separate library just with the banana. So you only have to import the OpenEdX events library, which is a tiny library with all the definitions, and then you can work on top of that. And that the public promise is that those same events will be at the platform just in the same way, because the platform also imports the same library and runs from there. Events are very strictly defined, and the definition is versioned in a very strong way, so that anything that changes will trigger a breaking, or anything that changes and triggers a breaking change will be noticeable. So as a developer, you will not be left in the dark saying, is this supported? Like, will this work? Like, I don't know, not make, does it have this field? It will have it, or you will notice it because the field, the name of the event has to change and the major version has to change. And they are also documented in line with the piece of code that is executing them. So you can quickly search, like text search for the string of the name of the event that you want and see exactly what's happening afterwards. Because open source, you can read the code, right? Now, on a more technical level, events are standardized Django signals. It's like a high-level signal. We are used to Django signals that are like the model saved, something happened at the database. But these are standardized Django signals driven more by a domain, like a learning domain context. So the student enrolled is not a record was created for this class at the database. No, a student registered. That's something I can understand. That's something I can attach my business logic, if you will, to the fact that a student registered. They are sent data attribute classes, which is very, very stable. It's a little bit more work to define an event this way. Why is this running? It's a little bit more work to define an event using data attribute classes, but it's a lot more stable. And remember, events are all about stability. I don't know why it's jumping. What? Sorry. Yeah, I think it's getting nervous. I am getting nervous. And I can see the mouse here and it's jumping all over. I do not know, but I think we're back in the right place. No. Okay. Okay, now we're back. I switched the mouse off, so no mouse. So data attribute classes are a lot more stable, and they are a little bit more costly to write for a developer, but not so costly that they are actually a problem. It's easy to write, and it's a big guarantee that if I read a user's name or the ID from a course, it will always be there for me. Another big part of events, and I've in the hallways I've talked about this, is that they run in process. The idea or the main idea for this was extending using plugins back to the fundamentals. And this will run in the same Python process as does edX platform. But there is a big push of work by edX to make the event bus read these events, these very same events, and take them everywhere. Maybe you want them in a separate ADI. They will come from the same definition. It just they are messaged to you via the event bus. You can think of it as having a private discussion or having a microphone that just sends this audio everywhere. This is kind of where how it works, but the definition of the event will be the same. So the promise of I can develop on top of this information, on top of this, the presence of the event, it will remain. And preparing for that, knowing that the event bus was something that was going to come at some point, we made the naming be already compatible with the OEP41, so that the events will be easy to translate from there. Those are events. Filters, on the other hand, are all about flexibility. So let's look at that. They do affect the application execution. So it's not that the application will stop and wait for the event. It will, but more specifically, it will respond to the filter. On the filter, you can say things like, stop what you're doing. You remember that enrollment you were going to make? Not, stop, don't do it. Or vice versa. You're enrolling into this? Okay, I also want you to enroll in something else. The registration, you need to have a certain field in your metadata. If you don't have it, I'll fill it in for you. So they affect the application flow. They give the developer total control over the process. So you want to extend, go ahead. The knife is very sharp, but we want you to have a sharp knife so that you can manipulate the memory objects. It would do no good to have the filter send a stable data class, and then you read from the data class and import the memory again. It's the same because you need that in-memory object to actually be able to operate and do amazing stuff. I know you will be writing amazing stuff on top of this, so filters are there to give you flexibility, are there to give you this capacity. The main design goal is flexibility. They are also documented in line, they also live in a separate library, and they are also versioned with the same strict semantic versioning rules that apply for events. Now, on the technical side, the filters are a set of functions that execute right before or when something's about to happen. You are going to render that dashboard? Yeah, just let me execute this little bit of a function before. And they are based on a pipeline mechanism that we heavily inspired on the mechanism for the third-party authentication pipeline. And that means something with the diagram I have there that I can no longer point to. But the idea is you have like a dictionary of arguments that will pass to the first step in the pipeline, and then to the second, and then to the third. And each step of this pipeline is either able to modify that dictionary and will therefore modify what gets to the other filters. But then at the end, the application will respond to this dictionary and continue its flow with that dictionary. So say a registration filter has a field for the username, for the name, or for something else, the password. I can modify the name, or I can modify the username and make it a computed username. I could still alter the frontend using other mechanisms, micro frontends or whatnot, and don't even ask for a username at all, and then create a username on the go, because that what I return at the end of the filter is what the platform will be fed in order to create that registration. But also at any point in those pipeline steps, I can also raise exceptions, and since I read the code and I know what those exceptions will do, I might decide that I want to redirect the user somewhere, or that I might want to alter the template that's being rendered, or perhaps present the user with a message saying you cannot enroll in this course via this mechanism, email this or that, go to this other URL, perhaps contact your administrative office at the university. This is the pipeline mechanism, which is only useful or only needed for filters. This pipeline also respects, and here it's important that it respects the the ordering of the functions, so that you will be able to set up that. And it's configured using Django settings, so it should be very easy to do for someone who's familiar with the library. On a side-by-side comparison, here we have on the left side, we have events or filters that are happening at the platform. So this presentation we borrow from Dave Ormsby when he tried to present these ideas internally at edX. And the idea is, when something happens, that's an event, and you get that signal. And then you get, in your plugin, the capacity to say, I will respond to the signal. So if Dave enrolled in a course, then I can listen for the signal, and I decide that sending a t-shirt to Dave, that might be an expensive task. I need to call upon APIs that are slow, but that's what I need to do. I need to track UPS, sending, whatever. So I can define an async task and do all my processing there, and all this logic, which is only needed for my institution, for my academy, all that happens in the plugin that doesn't require the core. In the case of filters below, as it happens before something, or when an action is about to occur, then I can question if the action should occur or not. So if instead of saying Dave enrolled, I say, can Dave enroll? I'll pass some data to say if Dave enrolls, and then my plugin code can look at whatever bizarre logic I might have. Like I will not let Dave enroll if he is not a dog person, and if he is, then I'll just answer with an exception, and the application will throw a forbidden response. So thanks, Dave, for being a good example of how to use them. Down at a technical level, OpenEDX events are, as I said before, signals. So you connect them as signals in the plugin. You have a signal path, which is something that should read naturally for Python developers. So you have the events library, the domain of what you're looking to respond to, so learning, or perhaps it's authoring, then the signal, and then a clear name of what the action you're responding to. And then on the receiver function name, you will have your own function. I'm here having an example of how to send this to a webhook, something relatively simply. But this is it's in line with what Django does for configuring signals. So it should feel right, like you're right at home. Now you have the definition. So if I see here course enrollment created, I can go and look at the course enrollment created definition, and I know that in the data it will have an enrollment field which contains course enrollment data, which is also defined in the same library, just some lines above that. And then I know exactly that course enrollment data contains the username, the user name, and it also contains the course ID of the course. So with those three, I can do almost any integration that I want. And I know this, and that's the public promise of the events, that I will have those fields in my code. And then I can write my own event, whatever I want. Here is an example of how I would use that to send to a third party some HTTPS call saying this is about to happen. I have a semi-live example. So we are using the click and roll button now. I thought I could pause it, but on the right, the code will stop twice. Once just before it sends it to show that that's the platform code sending it, and then on the event. So I can respond to both of those things happening, and I can write my code in there without having to ever touch the code. The student will see nothing, but I get on my third-party server, I actually get a call with the data that was sent. And something similar goes for filters. These ones are configured in Django configurations. There is a new dictionary called OpenEDX filters config. And what I write in there in line 2, that is the exact name of the filter I want to connect to. I tell it if I want the errors to be loud or not, if I want the platform to actually fail, or if I want the the framework to eat the whatever exception and just continue. And then I tell it which following functions I want to be executed at that moment. And this is an example of how I would write a class for that. It is this is the definition of the filter, of the specific filter I'm using, course enrollment started, and I can see there that it has an exception called prevent enrollment. So I can raise that exception anytime I want during my code, and the platform will respond to that. So where my code, like the code I would have to write as an extension developer is this. I say I'm going to make a pipeline step, it's called stop enrollment, and when it runs, I want to raise the exception prevent enrollment. That means no single enrollment could happen in this platform whatsoever if this is activated. I expect the logic to be more complicated. Maybe I have invitation codes. Maybe I have all sort of crazy and awesome stuff that will be happening with this. But the good part is that now the developers of extensions are in control of this simple interaction, enrollment in a course. And it works similarly. When I click the enroll button, it will stop twice at the code where it's being executed, but at the end, the user will receive a visible error saying like you can't enroll in this because the filters say so, basically. The best news of all this is that this is a done deal. It's implemented and it's in master. At the moment, we have about 10 implemented events. Those are for student registration and login, enrollments, certificates, and some cohort membership. I'm especially fond of that last one, course discussion changed, because we did not write that event. That was contributed by someone in the community that looked at the framework and said, this is a good way to have my feature done. And he wrote the event, had us review it, minor change that was needed, and then he used this to build something in the platform already. So this is working already for at least someone in the community, which I'm super stoked about. And in the filters area, we have about 9 filters that are in the platform. The ones from the right side, those are actually in PR still, but we will backport them to Nutmeg so that when Nutmeg comes out, it has a complete list of filters and events that you can like count on and build on top of. Those are the long names, and we needed some long names, and I still see them, and I think they're too long. But those give you an exact qualified name of what you want to achieve, like what is that you're responding or you're filtering, what is the exact action. So the names of those should be relatively straightforward for developers to connect to. Those are, however, not the only filters and events I want to see. I actually want everyone in here and out there to write new filters and new events. And I wanted to take a moment to look at how this works in practice. So if we were looking at the enrollment hook, which normally has like something before an enrollment and after an enrollment, and I wanted to create an Open edX event there, what I need is, first I need to create the data attribute classes, or I need to make sure that they are. We made some that are good enough for the filters or events that are present in the platform, but I need to create like a promise of what I can show about the objects that are being manipulated, such as the course enrollment. Say I want to publish the course ID and the course name and whatnot, the mode I'm enrolling to. Then you would need to go and create the event definition. Those two actions happen at the Open edX events library, which is owned by the Open edX org in GitHub. So it was It was built by edX, but is now part of the OpenEDX core, and it's managed by the OpenEDX organization. And then once that's in place, then you can integrate that into the service, be that the OpenEDX service, and I hope in the future many other services. We'll talk about that in a moment. In the case of a filter, you don't need to create the data attributes because you're modifying in-memory objects. So it's just create a filter definition, as we all developers do, probably go to the definitions that are already present and take that as a live example. And then once that filter definition is written, you can integrate that into the OpenEDX service, into the edX platform service. So that's pretty much what the framework does. It makes it. Those are the technical bits, but what it does for developers is it makes it easy to upgrade, because if you're building on top of strong foundations and you know those foundations will be there by Nutmeg, then you're not so worried that everything in your code will break. Some things will break, and probably not because of events, just because platform changes, but it will be easier. We have been using this probably since Juniper, and we have been through 3 migrations by now, and it has made our lives so much better. It will make your code easy to test, because now you can import the libraries definitions, so OpenEDX events and OpenEDX filters, in your testing code, and you can test that your code works with those events. If the platform changes, it will require to change the library version, and then you know something broke. Like, things break, but you want them to break in CI, not in production. So it will make it a lot more easy to test, and it will make it a lot more flexible, because now you have access to the actual in-memory objects in the case of filters. The result of this is, as we all want, more decoupled code, which is always better than more coupled code, and faster development times. Ideally, it should also be consistent, because now we have one naming mechanism to say what exactly is what I want to extend from the platform. So I'm looking forward to working more with this and building on top of this. Now we're not done, because there's more work to be done. I want everyone to go and define more events and more filters, and actually use them to build more stuff that I never dreamed could be done. And we want to integrate this not only with edX platform, but also with other services such as credentials or course discovery, of whatever might be in the future for this. There are 2 more projects that are in the future work, or I consider them as future work for the Hooks framework. One of them is the stable APIs. We have moved the source of the fire 1 layer down, but now I'm sure that when implementing filters, some developers will go and import from openedx.core.django apps something, and now you're creating a new contract with the platform that, again, can change, and we want to create something that fixes or removes the fire from that and takes it 1 layer down. And the other thing that I want to see happening is the event bus that will take actually the filters and move them so that you can respond to them in different IDAs. That's all work that I'm thrilled to see happening, and probably will be working there and will be joining in all the channels, Discuss and Slack and all that, to ask for your continuous feedback on the way those are going. Finally, I'd like to thank Maria Grimaldi, who did a lot of this work and could not join us in the conference, but she was super happy to be here, and she's one of the new core contributors to the platform, most of it because of this work, and I thank her deeply for all the great work that she has done. And I want to thank Nimisha and Dave from edX that believed in this when it was a raw idea, and through conversations and through heavily and strongly punching the bag of ideas that we were throwing out there, made it a lot better. And also everyone that joined in the conversation and gave us feedback and reviewed PRs and commented on everything from the first public draft of the document to the OEB to the final code. So that is it, but I'll be happy to have and respond to any questions that you might have.
We have about 10 minutes for questions. Yeah.
Hey, thanks, Felipe.
Yep.
Where do I have to deploy my code implementing the functions?
For that, what you would do is you write an OpenEDX plugin. There is a cookie cutter at the OpenEDX org, but you write it there, and then when you are deploying code, you put this plugin that you wrote into the dependencies of OpenEDX. So if it's a private, in the private dependencies, if it's public, and the public dependencies, and then when you deploy it, then it will auto-install because it's a plugin, and then given these either events or filters, it will connect to them. In the case it is a filter, you also need to turn it on by configuring it in Django configs, and then you're set. No need to. The question was if you need to customize edX platform. Ideally not, because ideally you already have those filters in. There is no assumption on what the filter might do. It will just respond to what you do with it.
Is there example code available somewhere?
There is. Thanks for the question. So this OpenEDX filters samples that says there, that's actually a project that you can find in GitHub under the EduNext organization. So GitHub/EduNext/OpenEDX filters samples, and you will find like a bazillion samples we wrote for testing because we wanted to test against those are already public.
Is there a place where all of the different hooks are documented?
Yes and no. So events are already documented in the platform. There is this docs directory, and in there we made a list of hooks that like has links to the places where the code was, and that's only for events. But thank you for reminding me, because we need to write the same page for filters. We will do.
They did a lot of really nice work with the waffle switches. So there's like automatically generated documentation. So like being able to use something like that would be nice to keep it close to the code. And,
we toyed with the idea, and we actually went in and wrote like extensions for not the waffle flag, but actually being able to define a filter. And at some point it was like, we need to get filters done. So we turned around and continue working on filters. But that is a work we'd be super happy to get on.
Yep. So in my experience, filters and events are so powerful that you can actually re-implement part of the core. Mm-hmm. So I wonder if you could start using filters to re-implement the plugin mechanism, such as like auto discovery of URLs. So it would be possible like to create a filter that would inject URLs in edX platform.
I've never thought of that, but it would be possible. You could. The same mechanism that you use for writing a filter, say, right before the enrollment, could be used right before the URLs PI module runs. Yeah. So you could have that, and it outputs like more to the list, and it just gets appended. So yes,
because it's a common problem that people have difficulties implementing plugins for edX platform.
Yeah,
and if there's the same mechanism for everything, then it becomes much more intuitive.
Yeah.
But then it doesn't play well with the event bus because it's all asynchronous.
I don't know enough of the event bus to comment on it, but yes, it should be possible to alter like things like URLs using the pipelines for the filters.
I know a lot of modern event buses focus around reliability via like at least once messaging delivery. With the Django hooks, is there any guarantee that those events are going to be handled? Is it, since it's all in process, if the process crashed, do we have to worry about that if we're going to start re-implementing core, for example, in events?
So events are implemented on top of Django signals, and they have Django signals have two mechanisms for sending. Like you can either send or send robust, and we made it so that all of them are sent robust unless you go to the definition of the event and say that you want it to just be sent. So if you don't go out of your way, there is like the guarantee that it will work.
Thank you.
There is a library, event tracking library in OpenEdX, which is basically responsible for emitting events. How different this events library is from the built-in OpenEdX library?
Sorry, come again.
There is already an event tracking library, which is basically responsible for emitting events within OpenEdX and tracking them. How different these events are from those ones?
I would say they are fairly different. The idea of the events that are used for tracking, if I understood correctly, those are only going to be catched by the logging mechanisms, and so these are more like broadcasting the connection to the signals. So for the events part of the framework, we are only making like a public promise that these signals will exist in that way, but the underlying mechanism is Django signals. So you could even argue that this wasn't necessary because you can always like connect the signal to the course enrollment save method, but that could change, or perhaps someone could change the model course enrollment, and then as a developer you never notice it. But instead, with the events framework, there is a public process that a public promise that this event will exist. And even if you change the class that implements enrollments, or maybe you create a different API that allows you to create enrollments in a different way, the platform should still respect that the event needs to happen. And that is a little bit for us developers to maintain. So.
This is kind of an extension of Zia's question, which is maybe a restatement of it to an extent. You know, let's say there's an event that's focused on pausing a video, and it has a canonical definition. A signal can be attached to it to respond to somebody pausing a video. At the same time, the event layer for logging is emitting an event saying this learner paused the video. Is the right thing eventually that we have like a shared semantics across these two things, and maybe events are emitted by a signal rather than a call to emit event or whatever, I forget what the name of the method is. And we unify these things so we don't have divergent views of what the event names are, what their meanings are. General question.
So, I mean, if we are going to standardize those events, so in that case, are we going to deprecate the event tracking library, which basically emits the old style events?
So that's a lot to unpack, but for that event, like when we emit tracking events, those tend to be very lower level, and like sometimes they are higher level and sometimes they are lower level. Like pausing a video is a very lower level action, and this is designed mostly with higher level actions in mind. But we also emit an event when a student enrolls in the course. So there might be some value in at least sharing the semantics and say, this is the event that's happening, and calling it the same through and through, which is why I'm so happy that we didn't invent the naming, but instead just borrow from the naming that was used for event bus. And that allows us to simplify in that everything should, like every event will have the same naming mechanism, and we're just creating events that were not there before, but they can be counted on from now on, kind of.
About time, so I think we can wrap up there anyways.
Perfect.
I just want to say to the recording, if Maria's watching, Maria, I really missed meeting you, but I'm so proud of your work on this, and thank you so much.
Yeah, I am.